Yes, so Srikal students, so today we will discuss Dalton's atomic theory. So Dalton was the first physicist or scientist who brought about clarity about the smallest building blocks of element, that is atom. So let's see what is the main postulates of Dalton's atomic theory. So we are going to discuss these postulates one by one. See that students, there is a difference between lemma, postulate, law, formula and theorem. Try to find out what is that. And postulate and lemmas are some of the basic things which cannot be proven. In mathematics we say lemma, in science we say postulates. Okay? Okay. So number one is every matter is made up of very small particles. We'll write it. Every matter, whether it is plasma, whether it is solid, liquid, gases, Bose-Einstein condensate, whatever it is, whether it is a colloid, some scientists believe that colloid is also different state of matter, whatever it is. Every matter is made up of very small particles. And what are these particles? Any student? What are these small particles Dalton is referring to?
Atom.
Correct. So these are known as atoms, called atoms. Every matter. Now, when we talk about matter, here the matter means elements as well as compounds as well as mixtures, possibly anything, anything and everything you can imagine, which has mass, which occupies space, is a matter. Am I right? Obviously not heat, obviously not radiations, obviously not feelings. Okay. So every matter which is made up of very small particles, right? Atoms. Now you might think that, sir, if H2O is not an element, it's a compound. It's made up of two elements, that is hydrogen and oxygen, right? So, but then this is a molecule. This is a molecule of water, molecule of H2O. And this molecule is also made up of the atoms of hydrogen, two atoms of hydrogen, and one atom of oxygen. So, this is correct that every matter is made up of very small particles called atoms. Right, students? So, let's see what is the second postulate of Dalton atomic theory. Okay. So, he says atoms are indivisible. Atoms are indivisible. So what is the meaning of this? You see that, students, uh, if we talk about 15, let's understand this by maths. So 15 has factors 5 and 3. Am I right? But what about 5? We can say that, okay, somebody can say that 5 is also having factors 1 into 5, but let us say that, let's ignore 1. So then we say that, we can say 5 doesn't have any factors. We can say like this, if we don't consider 1 as factor of 5. So this is the important thing, that these are like, we are able to break 15 into 5 and 3, the factors, right? We are able to break 20 into factors, like let's say 5 into 4. Okay. But then 4 can also be further broken into 2 into 2, but then 2 cannot be broken. Again, I'm saying the assumption that let's see that 1 is not the factor of these prime numbers. Okay. So atoms are indivisible. He says atoms cannot be further divided. That's what Dalton said. These are indivisible particles which can neither be created nor be destroyed, which cannot be created and they cannot be destroyed in a chemical reaction. So, students, actually, Dalton's postulates help us to explain the laws of chemical combination. So, to see the laws of chemical combination, refer to our previous video. What is the first law of chemical combination? Can anyone tell me? Maybe Sargun Kaur?
Law of conservation of mass.
So that says that mass can either be created nor be destroyed during a chemical reaction. So see that, students, this second postulate is justifying the first law of chemical combination, that is law of conservation of mass. See, it's explaining that atoms are indivisible particles. They cannot be created, they cannot be destroyed in a chemical reaction. So let's say we have sodium carbonate plus we have hydrochloric acid HCl, and that is giving us carbon dioxide plus salt, that is sodium chloride, right? Now students, see, during this chemical reaction, if some atoms of HCl or some atoms of sodium carbonates are getting destroyed, then the mass of the products will never be equal to mass of the reactants. Or if some new atoms are being created, then maybe the mass of products will be more than the mass of reactants, but this is not happening. So, this postulates is really justifying the law of conservation of mass, because atoms are atoms cannot be created, they cannot be destroyed during a chemical reaction. So we can say that the mass balance is there. The mass of reactants is equal to mass of products, right? This is the second postulate of Dalton. Let's go ahead. Let's discuss the third postulate. It says atoms of different elements have different masses and chemical properties. So students, you see that we have so many elements, right? Right, more than 110 elements we have. Now let's talk about iron and let's talk about copper, right? Or let's talk about aluminium. Let's talk about these three elements, right? So they all have their atoms, right? But now Dalton's third postulate says the atoms of different elements have different masses and chemical properties. Well, this is true. This is true till date. This cannot be, we cannot say this is wrong, because we know that iron's atomic number is different, copper atomic number is different, aluminium's atomic number is different. When their atomic number is different, their atomic masses are also different. Am I right? So different elements have different masses and chemical properties. Obviously they have different chemical properties, you know. Now these chemical properties are a result of, this is the nucleus of the element, and then you have these orbits in which the electrons are evolving. So every element is having different valency. What is that? Number of electrons in the outermost shell, which will participate in the chemical reactions. Am I right? Related to that, valency is related to that, number of electrons in the outermost shell. So when their valency is different, the way they will react during a chemical reaction will also be different. Beautiful. So this is the third postulate of Dalton. So, yes, Falgun, can you repeat what is the third postulate? Yes, correct. Have different masses and different chemical properties. Beautiful. So now we will go for the fourth postulate of Dalton. Well, it's saying atoms of given elements. I'll write here atoms of given element are identical in masses. Very, very important. Are identical in mass as well as chemical properties. Chemical properties. So what does it mean, students? It means, let's say, we have gold, a U. Okay. So if you take 1 gram of gold, it will have millions of atoms. But all those atoms will be identical. That's what the Dalton told. Whether it is true or not, that we will see later on, not right now. Because when we talk about chlorine, you will learn later on that this postulate was proven wrong. There are some isotopes. We will take those concepts later on. Isotopes of chlorine, isotopes of hydrogen. As such, we know if I take an atom of hydrogen, this is the nucleus of hydrogen, this is the orbit. In this orbit, we have one electron and we have one proton here, right? But then there is a different isotope of hydrogen known as this isotope is known as protium. And then we have deuterium, and then we have tritium, another isotope of hydrogen. In deuterium, students, interestingly, in the nucleus of the hydrogen, in this other isotope of hydrogen, there is a proton, and interestingly, there is a neutron also, and valence one electron. This is same. In the tritium, tree, tree means three. So then, very interestingly, students, you have one proton and you have, interestingly, two neutrons. Wonderful. So the total number of nucleons. What is nucleons? Nucleons means the protons plus neutrons. Together we say them nucleons is 3, and the electron is again 1. So you see, the way they react will be same, all the 3, but their masses are different because atomic mass, we know, students, is mainly because of 99.99%. The atomic mass of an element is because of, any student? The atomic mass
Nucleus.
because of, protons, neutrons, or electrons. We have discussed in the last video. Electrons are almost mass
Massless.
massless. Very right. Electrons, we can say that they don't possess any mass. Okay. So most of the mass of the atom is because of protons and neutrons. And see that here proton neutrons are 3, proton neutrons are 2, here they are 1. So this postulate of Dalton was proven wrong later on. Same is the case with the chlorine also. That will take up later on. So, but anyway, what was the postulate? Atoms of given element are identical in masses and chemical properties. Students, this postulate with most of the elements is true. You cannot say that this is not true at all. It is for most of the elements it's true, because if you take gold, or if you take iron, or if you take aluminium, if you take 1 gram of these, They have millions of atoms. All the atoms will have same atomic number. What is atomic number? Number of protons in the nucleus of the atom of the element of these elements, right? And they'll have same mass number also. Obviously, then we can say that they have same mass also. And chemical properties means number of electrons. Number of electrons, right? So they have same chemical properties also, because electrons, sharing of electrons actually decide how the chemical reaction will happen. But yes, there are heavy metals, uranium, plutonium, so their nucleons, this nuclear energy, that also, tells us how, they will react, fission, fusion and all. Okay, so this is the fourth postulate of Dalton. Okay, students, let's discuss the fifth postulate. Now, atoms combine in the ratio of small whole numbers. Atoms combine in the ratio of small whole numbers to form compounds. To form compounds. Okay, atoms combine in the ratio of small whole numbers to form compound. Okay, student, anybody can tell me that this postulate verifies which law of chemical combination? Can you make a guess? Read once again.
So law of constant
Love.
proportions.
Beautiful. Beautiful, Monrose. I'm so happy. Law of constant proportions. Can you tell Monrose Deepkar, that what is law of definite proportions?
So it was in a chemical reaction, chemical substance, the elements are always present in definite proportion by mass.
Beautiful. So happy. You have stated so clearly. So if it says, if we have H2O, right? In H2O, the mass of hydrogen is 1. There are 2 atoms. So 2U would be the mass of hydrogen. And atomic number of O is, I think, 8. So 8 to the 16 would be the atomic mass of oxygen. So 2 is to 16. 2 is to 16 means 1 is to 8 would be the ratio by mass of hydrogen and oxygen in any given quantity of water. Very interesting. Means that there's a definite ratio, there's a definite proportion. It's not that, you know uh, this cannot be 1 is to 7, this cannot be 2 is to 9, this cannot be 1 is to 10. It will be always 1 is to 8. So here the base of this is explained, by Dalton postulate. How great the physicists must have been. Though so many of his postulates are proven wrong today. He said atoms are indivisible. Now we know we have protons, neutrons, electrons, so we can further divide atom into, these subatomic particles. But still, at that time, when people were not really, most of the people, they were not really knowing that what is the atomic structure, what is the, what is the main building block of an element, or a compound or a mixture. The Dalton postulates really, helped in more understanding at microatomic level of the matter. So this postulate says atoms combine in the ratio of small whole numbers to form compounds, and hence the ratio. We got this. ratio. Okay, students. So last point, that is sixth postulate of Dalton, is the relative numbers. Please write down relative numbers and kind of atoms and relative numbers and kind of atoms are constant in a given compound. This law also strengthens or explains the second law of chemical combination, that is law of definite proportions. It's given here. The relative number and the kind of atoms are constant in a given compound. Means again, you see, if it is a molecule of H2O, then in one molecule of H2O there cannot be three atoms of hydrogen, or there cannot be two atoms of oxygen. One molecule of water will always contain two atoms of hydrogen and one atom of oxygen. That's what is explained in the law. Relative number and the kind of atoms. Kind of atoms. You see, kind of atoms means this one atom of hydrogen, two atoms of hydrogen, one atom of oxygen are constant in a given compound. So students, here comes the understanding that how the matter is composed of beautiful in a beautiful way. So Dalton's atomic theory, really speaking, was a milestone in understanding the basic nature of matter. Wish you all the best. Don't forget to subscribe and share our video. Thank you very much.